Hi, my name is Mason Nelson, and for my honors capstone, I decided to make a touchscreen-based video game controller, which I call Project Amussis. Amussis is Latin for precision, and the idea here was to create a video game controller with infinite precision and infinite customizability. I first came up with this project when I was browsing around on Instagram one day and saw a concept for a touchscreen-based video game controller. This was at the time when the next generation of video game consoles was about to come out, and everyone was wondering what they would look like. And after seeing this concept, I thought, no one has done this before. I researched it, and no one had made one before. And so I said to myself, why don't I make one? And so that's what I've set out to do this semester as I've created my capstone. To start off, a couple semesters before I started constructing the device, I had to get some inspiration together. And aside from the concepts that I did find online, I took a look at some of the sold video game controllers that have been on the market over the past 10 years. Some have included touchscreens and other touch-based devices, like Nintendo's Wii U gamepad shown here, which puts a touchscreen in between all the video game inputs, or perhaps Valve's Steam controller, which uses trackpads instead of joysticks, or perhaps Sony's DualShock 4 for the PlayStation 4, which uses a trackpad in the middle. But none of these were using these trackpads or touch inputs as actual input devices, the primary input device for the video game controller. And so there was no customizability there. And so I thought it would be best to go out and make a touchscreen-based video game controller. From there, I had to figure out how I wanted it to work. And I knew that I would have to have some sort of microcontroller, which started off with an Arduino, and now I'm upgrading to a Raspberry Pi. And the microcontroller has to interface with both the video game console or computer and also the touchscreen, because the touchscreen is itself an input device and an output device for the screen, but mostly an input device for the human touch. And then the microcontroller can't just allow the touch to go straight to the computer. It has to translate that into video game controller inputs, following the specific protocols before the computer can use that. For some background, there are a couple different formats for video game controllers. The most generic is called HID, which stands for Human Interface Devices. And this doesn't just include video game controllers, but it also describes mice, keyboards, and many other input devices that are in computers and game consoles nowadays. That was the first option, but I thought it would be much better to use direct input instead, which is compatible with the PlayStation 3 and most computers, and has become pretty standard for video game controllers across the board. So most controllers that plug into computers nowadays are compatible with this format called direct input. And most games that are supportive of controllers on PC nowadays support direct input. There was one other option, which was X input, which is for Xboxes. But that was not really an option for this project, since X input requires an additional security chip in order to interface with any Xbox console. And that requires licensing and money, and was much too much for this project as it is right now. So with that, I went with the direct input format. And that did require the microcontroller not just to be able to plug into a computer, but to emulate any USB device, which was a challenge along the way. Some microcontrollers just don't support that. So I had to find the right microcontroller in order to do that. But now it does interface over USB, and it takes the inputs from the touchscreen, and then it translates them and then sends them to the device. And the microcontroller also generates the screen, the picture that goes on the screen. That is not done by the computer. So future improvements that I want to make for this project, I would like to add some sort of tactile functionality. I think the reason that no one has made a project like this before is that when you're playing a video game, you're looking up at the screen and you can't really look down on the controller to see where your fingers go over the buttons every time. You need some sort of tactile input in order to figure that out. And so I plan to explore a couple different options, one of which includes adding these stickers that feel like buttons that can be removed and put back on after the virtual button layout changes. That's one option. They also make out on the internet suction cup video game sticks, which you can put on phones for mobile gaming nowadays, but it would work just as well with the touchscreen based video game controller. And then one other option is to research this technology, which has little bubbles in the touchscreen itself that fill up with fluid or release the fluid on command. And so I've seen this used in phones before, where the keyboard for texting will fill up with these little bubbles of fluid that feel like bumps instead, and then people will be able to type on them. And I think that could be a good improvement for this project in the future. As I was mentioning before, with the X input requiring a security chip, I would like to obtain that licensing one day in order to allow the touchscreen-based video game controller to interface with modern consoles, going beyond the PlayStation 3, which is compatible without a security chip. I would like to see that in the future. And then also, I'd like to add Bluetooth support, so it doesn't have to be just a wired device, that it can communicate over wireless communication instead. And then finally, I would like to add a software that users can use to create their own profile editors, because gamers like infinite customizability, and moving away from the base layout, which is shown here, which is available on the device right now, would allow players to get whatever button layout they want, tailor it to any game that they want, and make it infinitely customizable. I see this for broader impact in the area of accessibility. Within the last 10 years, there have been improvements in accessibility for video games, with Microsoft releasing an Xbox adaptive controller, which allows people with disabilities to connect to any device that they might use for anything else in order to control their video games. And I could see this infinite customizability as providing much accessibility to anyone with a disability who couldn't normally play other types of video games. So those are the future improvements that I plan to make. I would like to turn this into a product down the future after graduating. I would like to hire some other electrical engineers mostly, since that's not my area of expertise. It was definitely a challenge in the project when there were electrical failures. I had to just replace the devices instead of knowing exactly what went wrong. And I would provide that as a recommendation to any Capstone team members in the future to actually make a team, and don't do it on your own, because having more people with a more diverse background will allow you to make the product better and actually usable for the future. So those are my plans, and this has been Project Amussis. Thank you for watching.